On page 133, at the top, we are talking about equivalent fractions. So let's start by reading this little story. And before I even look at the story, my eye goes to those measuring cups because I'm a visual person. I need to see a diagram or a picture before I will fully understand something. So if you look at these two measuring cups, the first one has a lot more lines than the second. Okay, that's the first thing that jumps out at me. There are more lines right here than there are here. So my brain immediately wants to know how many lines are there. And it's really not the lines that we're interested in, it's the sections that we're interested in. So by section, I'm talking about this part, that section. Then here is a section. Okay, there are 3 sections. So I want to count those. I know that here's 1. Let me get a different pen. Here's 1, here's 2, 3, 4, 5, 6, 7, 8. So there are 8 sections. That means that anything about this cup has a denominator. The bottom number is 8. Okay, because remember, let's look back. A denominator is the number of equal parts in the picture. So here we have 8. And on this one we have 1, 2, 3, 4. So the denominator here would not be an 8. It would be a 4. So let's suppose that you and I are taking a cooking class. And your measuring cup has 8 sections and mine has 4. And the teacher tells us to put some chicken broth into our measuring cups. So you put your chicken broth in and I put mine in, and we have equal amounts of broth. We're not doing anything wrong. We both have the same amount of chicken broth. It's just that yours is measured in smaller sections than mine is. So your cup has 6/8 of a cup of chicken broth, and mine has 3/4. But we can look at those and tell it's the same amount of broth. Doesn't matter what kind of measuring cup you have, that amount of chicken broth that's needed for the recipe does not change. There is more than one way to write a fraction to represent a given amount. For example, the 2 cups contain equal amounts of milk. That does not look like milk to me, but that's beside the point. The cup at the left is divided into 8 equal sections or measuring units. The cup at the right is divided into 4 equal measuring units. The fractions 3/4 and 6/8 represent the same amount. The 2 fractions are called equivalent fractions or equal fractions. So let's stop right there and come over to a notes page and define those terms. Equivalent or equal. And those 2 words always mean the same thing. And to me, a picture's worth 1,000 words, so let's start there. In this one, I want you to draw a rectangle. It does not have to be perfect. In fact, mine is not, so let's add it. Just sketch something that looks similar to this. It does not have to be perfect. Okay, draw a line down the middle, going this way. A line down the middle, going this way. And then one more line here. And one more line here. So any fraction I write for this picture, count your sections. How many do you have? You should have 8. And then right beside that one, let's draw another rectangle the same size. You can always pause the video. So the whole unit is the same size. But in this rectangle, I only want you to draw this line. So the denominator for this one would not be an 8, it would be a 2. So we have 2 cakes that are the same size. The first cake will serve 8 people. The second cake will only serve 2. All right, let's start with the second cake. And I want you to take your highlighter or pencil, whatever you're using, and let's color the top section only. Okay, so I have shaded 1/2 with yellow. How many of the squares in the first cake would I have to shade to equal the 1/2 in the second cake? Well, I would have to take this whole top row, right? Those are equal amounts shaded. So I know that this is 1/2, and this is 1/8. There's an 1/8. There's an 1/8. There's an 1/8. So in this one, I have 4/8 that I have shaded. And here's what we're getting at. This is where the magic happens. 4/8 is exactly the same amount of cake as 1/2. 4/8 is equal to 1/2. They are equal fractions. Okay. So you might be thinking, so how do I figure this out without having to draw these cakes? And actually, I'm going to ask you to draw one more. I'm going to ask you to draw pies this time, because I need some examples to show you. So let's draw a circle. This can be pizza or it can be pie, it doesn't matter. Let's cut it in half this way, and let's cut it in half this way. Let's cut it in half this way. Oops, try again, try again. I need that X to go right through the middle. We'll just have to pretend, sorry. All right, so the denominator for this pizza is what? How many parts are there? There are 8. Okay, so let's draw another circle. I should have copied my circle. It is so hard for me to get them to be the same size, but I'll try. It's pretty close. Okay, on this one, let's cut this way. And let's cut this way. So the denominator for this pizza would be 4. So on the first pizza, I can feed more people, but everybody's getting a smaller slice. All right, let's do some shading. Let's do, on this one, let's get 1, 2, 3, 4. Let's go ahead and do 4 of them. So we could say that 1/2, 4/8 is shaded. And I'll actually come back to what I was about to say in just a minute. Just hang with me here. 4/8 is shaded because here's 1/8, here's 1/8, here's 1/8, and here's 1/8. That's 4 of them. 4/8 is shaded. So over here, what would I have to shade to make an equal section? Well, I would definitely have to take this one and this one so that I get that whole bottom half of the circle. Okay, so this is 1/4 and this is 1/4. So we could say that 2/4 are shaded. Okay. So what if I come over here and I want you to do the same. Let's draw one more circle, the same size. And let's cut it this way. One cut. So the denominator would be what? How many parts? 2. And if I want this one to match the other 2, I need to color this bottom half. So this pizza would only feed 2 people, but it would give them plenty of pizza because the pieces are smaller. As that denominator gets smaller, the pieces get bigger. So here is 1/2, and that is 1/2 shaded. So using a picture, I can tell you that 4/8, 2/4, and 1/2 are equivalent fractions. Okay, if I have room, and I believe I do, let's do one more. Let's slide this over. Since we're kind of on a roll here, we won't have to draw it again. I want you to come over here and make one more circle, the same size. It's very important that we don't change size of the pizza. We don't want to change the amount of pizza, we just want to change the number of cuts. And see, that is too big. That is a size of a pizza that doesn't match the other 2. So let me shrink it just a little bit. Let's see if that's still a little bit too big. I really want it to be as close as I can get it. All right, so this time, let me show you how to draw this one. I want you to draw it using the thirds that we've done. So we're going to cut this way, and then we're going to cut this way, and then we're going to cut this way. So that denominator would be a 3. Then I want you to do a cut there, a cut there, and a cut here. And pretend those are all the same size. I'm actually going to try to rotate this if it will let me. And I'm not sure that it's going to let me. No, it won't. Okay. So I want to color half of this pizza. And I'm going to use this one. It's my drawing is not exactly right, but let's pretend that those are all equal pieces. That nobody gets a bigger piece than somebody else. They're all exactly the same. So for this one, I forgot to ask you before I colored, but it's okay. What would the denominator be for this pizza? How many people will this pizza serve? 6. And here I have 1/6, 1/6, and 1/6. And that is a total of 3/6. I cannot say that word. I have never been able to say that. But you know what I mean. So we could also say that 3/6 is an equal fraction to all of those. So equivalent fractions are important because they let us compare quantities, just like that measuring cup. Your cup has 6/8, mine has 3/4, but we have the same amount of chicken broth. All right, this rule says to find equivalent fractions, you multiply the numerator and denominator of a fraction by the same number. So we have some examples over here. They want us to change these. Now, before I show you this, I want to show you something else. Come over here with me to this page again. Let's suppose that you have 3 5/7. That is a mixed number. And we learned in the last lesson that for every mixed number, there is a twin. That's called an improper fraction. Remember when we were looking at those lemon pies and we said we have the same amount of pie in both scenarios? So how do you go from a mixed number to an improper fraction? How do you find this missing piece? Well, I used to tell my students when you need an improper fraction, you need to make the mixed number mad. But MAD is in all caps because it is an acronym for multiply, add, denominator. MAD, multiply, add, denominator. And here's how it works. The first thing I want you to do is draw what I'm about to draw. Put your pencil right here. Come around this way. Just like that. And let me do it again. I started here. I came around this way and stopped. And here's where the MAD comes in. You multiply, you add, and you bring over the denominator. We can already do the denominator. It's a 7. So whatever you have right here is the denominator over here. Remember, we don't have any control over that denominator. It has to just move over. So here's how you make the number MAD. You do 7 times 3. That's 21. And then 21 plus 5 is 26. So this mixed number, 3 5/7, is equal to the improper fraction 27 over 6. And we'll do some more. Let's do another one. Let's do 5 1/2. And I want to know its improper fraction. So we're going to start, draw the circle, multiply, add, denominator. The denominator is a 2 this time, so just bring it over. Then 2 times 5 is 10, and 10 plus 1 is 11. So that would be the top number there. Okay. Now our book gives us some more. It gives us these two, 2 3/4, 5 1/2 I just did. We already know that one. I just did it. So let's do 2 3/4. I didn't mean to do that. I didn't know what it was. Okay, 2 3/4. We're going to make this number mad. So we do that thing. Multiply, add, and denominator. Denominator just comes over. All right. 4 times 2 is 8. And 8 plus 3 is 11. So that would be 11/4. And we have done both of these. This one is 4 times 2 is 8, plus 3 is 11. 2 times 5 is 10, plus 1 is 11. And then they want us to write an equal fraction for these two. So I have 3/4 and 6/4. And let me show you how to do that one. Let's start with 3/4. And they want us to raise that one up to a denominator of 16. So they want me to build up this fraction to a denominator of 16. Okay. To get from 4 up to 16, I would have to multiply by 4. 4 times 4 is 16. And if you do that on the bottom, you must do it on the top. 3 times 4 is 12. So 12/16 is equal to 3/4. Okay, for this one, I have 6/4. And they want me to raise that up to 8ths. 4 times 2 is 8. So 6 times 2 would be 12. So 12/8 is equal to 6/4. And I'm going to make up one because I want you to see that this will also work. Let's suppose that you are using 3/5. And you want to raise that up so that there is a 12 in the numerator. The same process will work. 3 times 4 would give me that 12. So 5 times 4 would give me a 20. You are raising these by the same factor. And that's why you will get an equal number. Okay. I think I'm going to stop this video. This one was 4 times 4. So 3 times 4 would be 12. 4 times 2 is 8. 6 times 2 is 12. I don't want these videos to be terribly long, and this one's already long. So in the next clip, we will look at this bottom half about how to simplify fractions and mixed numbers.